Okay, part 2, velocity time graphs. Here we go. All right. Let's take a look at the first problem up here. First problem. Velocity time graph. So right there you see what you have. Set your axes up like this. X-axis is time, Y is velocity. Let me double check that it looks good on the screen. Hold on. Oh, perfect. Okay, good. All right, so let's take a look at this. Read the problem carefully. So we're giving you the story. You now have to put it on a graph, okay? Eventually you're going to go between position time and velocity time graphs. And we talked about in class, if we haven't already, we've said, here's your position time graph. Tell the story of what you see. Then draw it on the BT graph. So again, graph, story, graph, okay? You need a story in order to do a graph. So we've got a constant speed, positive direction. So we said the positive quadrant is up top, then negative quadrant is in the bottom. And if we put in easy numbers, -5, +5. Positive, negative doesn't mean, it just means direction. It doesn't impact magnitude. The value impacts magnitude, 5 and 5. So if I were to have, we'll take a look here, constant speed in a positive direction. So again, there's no change in V, so we'll just assume here. Constant speed, positive direction, horizontal line. Positive direction, top quadrant. Constant speed, horizontal line. Okay? So obviously the next graph is going to be VT graph, moving with a constant speed in the negative direction. So let's draw the same thing. Time, velocity. So no delta V, negative direction, work in the negative quadrant. So again, it's going to be here. So negative direction, go down to the negative quadrant, constant speed. Easy, but here's what I want to say. Let's bring this up here. If I said you constant speed, positive direction, I put it there. If I said you constant speed, negative direction, we're going to put it right here. So my question is this, and I'll color code these two. This and this. And I want you to take a look at the numbers over here. Here, you've seen that there. Here I've got a +5. Here I've got a -5. So here's a misconception, or here's an issue that kids run into with this, given that this is a BT graph. We know this is constant speed in the positive direction, this is constant speed in the negative direction. So my question is this, given this data, compare their speeds. Tell the story. A lot of kids think that this car is going faster, this object is going faster than this. Why do you think they would say that? Let's address this misconception. People say this is going faster than this. Think to yourself why that's inaccurate. Okay? Reason why is this. They're both going the same speed. By magnitude alone, they're both going at a rate of 5 meters per second. Okay? So this, we'll call this car A, and we'll call this car B. So A, right, is going 5 meters per second. Correct? Constant velocity, constant speed. B is going 5 meters per second. No, Miss Parsi, it's -5 meters. Wait a second, I didn't say that yet. Positive 5 meters per second means 5 meters per second in the positive direction. So we'll call this right. Here, 5 meters per second, yeah. In the VT graph, the sign means direction. So we'll assume if right is positive, we'll assume that this is in the left direction. So these two objects are going the same speed. But given that one is going in the positive direction, constant speed, one's going in the negative direction, one's right, one's left. So the speeds are the same, okay? But the velocities are different because they're going in different directions. And if you take a look at this right here, I'll do one other quick thing just so you see this. Take a look at this. Go back to the VT graph. Here's V, here's T. So here's car A. Car A, here's car B. So we take a look at this data. Both of these cars, A in B both have a constant rate of speed. Okay? So they're both going constant because there's no acceleration, no delta V. Because there's no slope. But let's take a look. What's car A's speed? Car A's speed is 5 meters per second. Car B is not -10, 10 meters per second. So right off the bat, which car is going faster? Car B. But it has -10. What did I say about signs on the VT graph? Signs tell you direction, okay? So A is going slower than B. But B, right, what's this negative contribute? Direction, because remember, velocity is a vector quantity, magnitude is the number, the sign is direction. So we could say that A is traveling 5 meters per second rightward. B is traveling 10 meters per second leftward. So again, even though it's a -10 value, be very careful. It's going at a rate of 10, constant speed. Same direction, constant velocity, 10. I hope that helps. Okay, keep that in mind. That's a big misconception we hit on in this section. Okay, so let's go back to this. VT graph for an object at rest. Easy. VT, rest. So then always look at the y-axis. Here's your T, here's your V. Anything above means I have a magnitude. Anything below means I have a magnitude and a direction. And above, magnitude and direction. So what shows me at rest? Horizontal line on 0. Rest. That means stop. Stop here. And again, read the axis. Okay? Read the axis. Let's skip down to this one. You guys should be able to do most of these. Let's try, I'll just do a few random ones. Set your axes, V, T. Here's the story. Velocity time graph, boom, boom. That's what you have. You have positive direction. So when you see positive direction, you want to work up top, in the top quadrant. Now you have acceleration. So there's going to be a delta V right here. So when you think delta T, you're going to have some sort of a slope. Okay? Because again, we're analyzing a change in velocity from fast to slow. Okay. Fast, magnitude. Slow, magnitude. So where's their fastest slow? So if I go 5, 10, if I need a slope going from a fast to a slow speed, I would go like this. Watch this. Linear downward. So this tells me, yes, I'm going in the positive direction. But I'm slowing down. I was going 10, 9, 8, 7, 6, 5, 4, 3, all the way down. So again, positive direction, top quadrant. There is a slope, delta V. Fast, high speed, magnitude-wise, to slow, magnitude. Okay? Our vector's been taken care of because we're in the positive direction. So that's that there. Hope that makes sense. Let's take a look at this one down here. Again, read the story. The story tells you everything you need. So velocity time graph. Set the axes up. T, V. Negative direction. So right now we're thinking of direction. So which quadrant we're going to work with? We're going to work with the bottom quadrant. We have acceleration. We have a delta V, so you're going to have a tangible slope. Fast to slow. So again, direction, slope, magnitude. So let's take a look at this. We're going to work in the bottom quadrant. We have a slope. Fast to slow. So let's put in our numbers. So again, -5, -10. Again, negative just means direction. 5, 10. So should I go from fast to slow or slow to fast? Fast to slow. From here to there. So again, negative direction, acceleration, we have our slope, our delta V. Fast, we'll just make up an easy number, 10 for magnitude, to slow, 1 to 2 in the negative direction. Okay? And again, to get ahead, because I know a lot of you know this, we see a positive slope. So you see this we have here negative direction, and we're slowing down. And now you should already know this, positive acceleration. Okay? Let's move down to skip around. Let's do this one. Let's take a look at this one. Okay. Velocity time, set your axes, vt. Again, positive, negative. Put in some easy numbers just to give you guys an idea what to do. Okay, -5, -10, right? I'll put that here. I'll just put it up here for you so it doesn't confuse you. All right? So you got velocity time graph. So look here. Okay, so constant speed. So no change in velocity. Positive direction, top, and then slow. So again, 2 horizontal lines. So we're going to work up top in the positive quadrant. And it says here, fast constant speed. So let's look at our magnitude. Why don't I start at 10? So here's segment 1. We'll break this up. Here's segment 1. Watch this. Fast constant speed. That should be straight horizontal across. And then with a slow constant speed in the positive direction. Almost instantaneously right across like that. So here's your positive, fast, constant speed right here. Positive, fast, constant speed. And then here's your positive, slower, I guess, constant speed. Again, here's your sign. Here's your magnitude up here. Okay? Hopefully that helps. Let's move down, next one. Or let's move down here. Why don't we try this one? I like this one. Velocity time graph. T on the x, v on the y. Velocity time. First it moves with a constant speed in the positive direction. And then moves with a negative acceleration. Okay, this is interesting. So let's take a look here. Let's put some information in, easy numbers. Okay. So we have a constant speed in the positive direction. And then we move with a negative acceleration. Okay, let's take a look here for a minute. So right here, we're going to go horizontal. Horizontal because there's no slope. Okay, we have a speed, we have a magnitude, but there's no slope because there's no acceleration. So no delta v. But we're in the positive direction. So you know what, we'll just start at 10. We'll just call it 10. So we'll start here. Excuse me. Horizontal line as best as I can draw it. And then moves with a negative acceleration. So we're going to assume, right down here, this makes you think a little bit, but it's easy. Positive direction. But we have negative acceleration. Move this up a bit. Can't move it up. Okay, I hope you can see it. Positive direction, negative acceleration. We need to talk about the speed. Does it slow down or speed up? Negative acceleration, so to get this, I need to slow down. So this becomes slow down. So how do I show this object slowing down in the positive direction? 10 to 5, positive direction. Watch this. Boom. So here's segment 1, horizontal, constant speed, no delta v in the positive direction. Here's part B, negative acceleration. We see down here, positive direction, slowing down. And again, remember this, and I'm going to write this up here. Positive acceleration gives you a positive slope on a VT graph. Negative acceleration, negative slope, and we talked about this on a VT graph. Okay? So hopefully this helps. This should clean things up. Keep attacking. The effort is unbelievable. I mean, this is outstanding. Again, if you have any questions, let me know. We're going to spend class time taking this graph and putting it onto a PT graph and vice versa. Okay? A couple other cool things you might want to see on Physics Classroom. There's some games on here you might want to check out. And again, you get through the packet first. Get the practice done first. This is the kind of stuff you should be doing in preparation for your test. So and we'll do this in class to some extent. You guys are used to being here at the physics tutorial, right? 1D kinematics, all this stuff right here. Pretty good stuff, right? But I would, if I were you, I would go down to, where is it? Minds on Physics, I think it is. Here we go. Is this what it is? Of course, now I forget. Wait a second. It is, hold on. I just found it today, of course. I put the link on your website, actually. Physics Interactives. Here's what I'm These are really cool. Physics interactives, that's what I want. So when you look here, go into 1D kinematics. These are great. Like graph that motion, name that motion. Take a look at this. Good stuff. I mean, it's actually kind of fun in a way. Click on Launch Interactive. Hopefully your computer at home can do this. Great practice for the exams and potential pop quizzes. Take a look at this. Begin activity. Pick an animation. Look at that. Ticker tape. Car going to the right. Positive direction. Seems like speeding up to the right. Okay, so then what you would do is pick one of these. Read this. Car moves with a rightward velocity and a rightward acceleration. So let's take a look. We're going right and we're speeding up. So keep in mind the direction of the acceleration vector. Do you think that's right? If you think that's right, you check it. So if you think, oh, watch this. Look at B. Read that. If you think B is right, you hit check. We'll go back to A. The car moves with a rightward velocity, rightward acceleration. It's speeding up in the right direction. Let's see if it's right. Check. You're correct. See how that works? It's pretty cool. Then you just go to animation 2. Same thing. Obviously it looks like the car is slowing down. It's going right. So the acceleration vector is left because the car is slowing down in the rightward direction. You would pick one of these descriptions down there to go with it. Again, really good review, interactive, and it's just a nice visual up here. And again, if you're not sure if you need to see it again, it'll replay it for you. So really good stuff here. Really exciting. Keep up the good work. Get her done. Let's go. We can do this. We got this. Good job. And that's that. All right. That's it for the video. Make sure you watch it.